Hi, everyone. Before we start with HAs, let's classify VAs, vertical asymptotes. First, let's review this exercise from section 2.5. We factored this polynomial over the reals, like so. And we found that 0 was a 0 of multiplicity 3. Look at the x cubed over here. And we also found that 4 was a 0 of multiplicity 2. Look at this, the square of x minus 4 over here. Notice the leading term is x to the fifth. Based on this information, sketch the graph of y equals f of x. I'll give you 20 seconds. All right, let's see what Desmos has to say. So let's try y equals x to the fifth minus 8x to the fourth plus 16x cubed. I could have also entered the factored form over here. Well, that's what we have here. So overall, we have a rising snake. That's no surprise if we zoom out. Okay, and we have two x-intercepts. We have an x-intercept at 0, 0, all right? And the multiplicity of 0 as a 0 was 3. It was odd. So that's why the graph cuts like a snake around this x-intercept. And notice here that the graph is particularly flat around the origin. The multiplicity is 3, not 1. Because the multiplicity is higher, we have more flatness here, more flatness near the origin. Now, what about the point 4, 0? We have an x-intercept at 4, 0. The multiplicity is 2. That means we have a bounce. All right. So we have a cut at the origin, 0, 0. And it's pretty flat because the multiplicity is pretty high. It's 3. It's odd, so we have a cut here. The multiplicity for 4 as a 0 is even, 2. So we have a bounce here. Overall, it's a rising snake. Now, the multiplicities here tell us about cutting versus bouncing on the x-axis, at the x-intercepts. But what if these factors were in the denominator? So what happens then? What if we have y equals 1 over x? It's this hyperbola, and the y-axis, x equals 0, is a VA. And in this case here, because as x approaches 0 from the right, this branch has y approaching positive infinity, and as x approaches 0 from the left, the y approaches negative infinity. So notice that the two branches are going in opposite direction. Y approaches positive infinity from this direction, y approaches negative infinity from this direction. Split infinities, split directions. For that reason, we call this asymptote in here, the y-axis here, an odd VA. Because you have these split behaviors around the asymptote. In general, if you have an odd exponent on the corresponding factor for x down here, you're going to get an odd VA. So 1 over x cubed, again, we have an odd VA. If we have 1 over x minus 1, all to the third, then we have an odd VA at x equals 1, where the branches go in opposite directions, this time around the VA x equals 1. So an odd exponent on the factor here, the multiplicity of a 0 in the denominator, if it's odd, then we have an odd VA. Now what if it's even? What if we have y equals 1 over x squared? How did the graph of y equals 1 over x squared look like? It was a basic graph. It was this volcano graph. But once again, the y-axis, x equals 0, is a VA. This time, however, the branches are going in the same direction. As x approaches 0 from both the right and the left, y, or the function value, approaches positive infinity in both cases. So here, the VA is an even VA. And that corresponds to the fact that we have an even exponent on the factor here. 0 is a 0 of the denominator with multiplicity 2. Likewise, if we had x minus 1 all squared down there, then we would have an odd VA at x equals 1. I'm sorry, an even VA at x equals 1. For that matter, if we put a minus sign in front, an opposite sign, well, both these branches go down, but they're both going in the same direction. The y-coordinate, the function value, is approaching negative infinity as x approaches 0 from the left and from the right.